So in the last section, we were discussing about measures of central tendencies. So coming back to the basics, we started with statistics and we are studying one branch of statistics, that is the descriptive statistics, that is basically about summarizing and describing features of the data. And one such feature of data is related to the central tendencies, and we have seen mean, median, mode, etc. Now we are moving to another feature, that is the measures of dispersion. So what do you mean by measures of dispersion? So suppose you are given a data. You are given a data like 1, 5, 10. Suppose you have 100, 1000, etc. Then you are given a data 1, 2, 5, 6, 7. So you can see that the dispersion for this first data set is significantly high. The variation between these values compared to the second data set. Here you can see the variation between the values is comparatively negligible. So how can you quantitatively measure this variation? So that is what we are going to study now in measures of dispersion. So in measures of dispersion, first we will take a look at the variance. So how to calculate variance? So variance means the variation in the data. Okay, so coming to variance, there are two types of variance. One is sample variance and population variance. This concept we frequently encounter this one, sample and population variance. Let us see what it is. So first let us look at the formula. So okay, let us look at a formula here. So this is a question is a researcher recorded the following number of hours spent studying by a random sample of 5 students for a recent exam. You are asked to calculate the sample variance. So the given data is 8, 10, 7, 8, 10, 7, 12 and 8. So let us first calculate the sample variance. So the formula is given by this one. So let us calculate it. So it is, you need to find the mean first, that is equal to 8 plus 10 plus 7 plus 12 plus 8 divided by 5, and this comes out to be by 5, it is 9. So here, if you want to calculate the sample variance, it is 8 minus 9 the whole square plus 10 minus 9 the whole square plus 10 minus 7 the whole square plus 12 minus 10 the whole square. It is 7 minus 9 the whole square plus 12 minus 9 the whole square plus 8 minus 9 the whole square divided by, here n is 5, so you will take 4. So I'll explain why we are taking 4 instead of 5. So if you calculate it like this, you will get it as 1 plus 1 plus 4 plus 9 plus 1 divided by 4, it is, so it is 16 divided by 4, it is 4. So this is your sample variance. So this is how you calculate the variance. That means the dispersion among this data. It indicates the dispersion, how different. See how different is the data. Okay, how spread it is. Okay. Now, coming to why we are taking the sample and population variance. So you can see that in this question, a researcher recorded the following number of hours. We have taken a sample of 5 students. Okay. Sometimes the actual number of students, it can be some thousand, 10,000, in millions, can be even in millions. But in statistics, it is not possible to measure the studying hours of all these students. So we will take a sample. So if we have a population, we will take a sample. So this is the sample. So suppose there are 100 students, that is the total number. We will take a sample maybe at 10. Okay, this is the difference between population and sample. Okay, so when you calculate the variance of sample, we will divide it by n minus 1. Sigma x minus x bar the whole square by n minus 1. This is called the Bessel correction factor. If you are calculating the variance of the population, then it will be divided by n. So this is one basic difference that we need to understand. Right, now let us dig deep into that. Right, so here comes the population variance and sample variance. Okay, so this is the notation for this. Here it is a square. So here the data source is entire population. Here we are taking a sample drawn from the population, and the symbol is this one, and the denominator is capital N, and here the denominator, note that this is n minus 1. This is the sample size. So what is the purpose of this one? It will give the true spread of the population, but here you are making an estimate of the spread of the population. It is only an estimate. So that is, so we will study about that in in depth in inferential statistics. Okay, that is what we are going to study after studying descriptive statistics. Now, so what is its nature? This is a parameter, a fixed value. It will not change. And this one is a statistic, that is something we got from the sample. This is an estimate of the actual value. It need not be correct. Okay, so this is the difference between sample and population variance. Now, okay, so this is the formula for sample variance and population variance. Okay, so we have seen what is variance.